Hello. Today I would like to share with you a piece of software that I wrote called Ethereum Bonds. The presentation is divided in 4 parts. In the first part, I'm going to describe the software. In the second part, I'm going to do a demo. And in the last 2 parts, I'm going to get a bit more technical. I'm going to show the user how to download the application and install it in their local computer. And lastly, I'm going to show the user how to use hard hat in order to compile the Solidity contract. All this software will be available in the GitHub link in the description of this video. What is Ethereum Bonds? It is a decentralized application, meaning an application that doesn't need a server in order to work. The backend of the application is the Ethereum blockchain. The application allows the user to issue a zero coupon bond in order to fundraise Ethereum. It deploys a Solidity contract in the Ethereum blockchain. The front end is built on React. The application was developed and tested using a local Ganache Ethereum blockchain. I also use a Ethereum development environment called Hardhat and a library for JavaScript called Ethers. This is free software under the general public license version 3. The objective of Ethereum bonds is to decentralize finance, meaning removing the middle person. By removing the middle person, the investor will be able to get a better return on their investment. Likewise, the borrower will be able to borrow at a lower interest rate. So how does it work? As I mentioned, it's a zero coupon bond. So we don't have to worry about coupons. The whole mechanism is based on the price differential between the selling price of the bond and the redemption price of the bond. The borrower sells the bonds at a discount and has to redeem the bond at parity. In this slide, ETH stands for Ethereum and ETB stands for Ethereum bond. So let's go ahead and check out the demo. Great. So I'm going to show you how the software works. And for that, I have Ethereum bonds open, and I also have Ganache. So Ganache replicates Ethereum here in my local computer. It runs on a local port. You can see it here. And we have 4 fake accounts, and each account has 100 Ether. That's also kind of fake Ether. And we access the private key by clicking here. So let's copy this one, put back this here, and we put the private key here. We need a private key in order to deploy the contract. Let's fill out this information. Something I want to say is I won't be able to go through all functionality in this demo. I'm just gonna do the shortest possible version. If you are interested in understanding better how the software works, I encourage you to go to the documentation. I'm going to do just the basic functionality here to show how it works. So fundraising goal, let's say 180 Ether. Initial exchange rate, that the discounted price that I, as a borrower, I'm going to sell my bonds for. So it will be 900 for 1,000. 900 Ether gives the investor 1,000 bonds. Number of monthly payments, let's just say 5. Fundraising days, let's say 30. If I cannot fundraise my goal within those 30 days, the investors can pull out their money without interest, but they can pull out their money. And grace period, I can give myself no grace period, but I'm gonna give myself 1 month in which I don't have to pay. So let's deploy this. Great. Notice that my account, my wallet got debited for a small amount. That small amount is the gas price I have to pay in order to get the contract deployed in the blockchain. So let's change hats. Let's get another key. And this hat is going to be an investor. I'm going to be an investor now. Notice that the contract address got populated after deployment. That's really important. If I am a borrower, I want to share this contract address with all the potential investors so they know where to invest. And I'm going to change this, and I'm going to buy 90 worth, well, 90 worth of bonds. Great. Notice that it got the contract info got updated and the wallet got debited. Let's change again hats, put another investor. And I'm going to buy this time 60. Perfect. And let's change hats for one last time. And I'm going to buy the remainder. Notice that here time fundraising ended is NA. It should turn now when I buy the last bonds, it should turn to a timestamp. So let's see it. So there are 30 to reach the goal. And there you go. The timestamp shows up. Great. So let me try to get the money out of the contract. And we can click here. Nothing happens. And nothing happens because I don't have the right validations. I am not the owner of the contract. I cannot get the money out of the contract. I have to get back the key. I have to get back the right key. Put it here. And withdraw all funds. Perfect. So all the funds have been withdrawn. Nothing left. Let's imagine, let's fast forward. I'm ready to pay all my investors. So I'm going to deposit enough to make investors whole. I could only deposit a small a portion. Maybe I just have enough money to make the first payment. I could use this function, but just for time's sake, let's put all the money back and enough to make the investors whole. So it gets debited, and now the contract funds is 199. And notice that it's not 180. 199 because we have to pay an interest to our investors. So remember, it is 5 payments. So let's make the first monthly payment. Good. Second monthly payment. Third. Fourth. I just want to say something quickly about this variable. It should be 80 and right now it's 79. It is a rounding error that has to do with the fact that Solidity has no float type. So when I make the last payment, this should turn to 99. You should read 100. The real number is 100. And this should turn to a timestamp, and contract ended successfully should turn to yes. So let's make the last payment. Great. So we have the 3 timestamps. Contract ended successfully turns to yes. And all the investors get back the money they invested plus a little extra, which is their interest. So perfect. Okay, so where is the server? Where is the database? Both the server and the database is the Ethereum blockchain or to be more specific, the server will be the Ethereum virtual machine, and the database will be the Ethereum blockchain. So no need for server. Let me show you a graph that shows kind of the standard functioning of a website that has a front end on React, and the back end in this example is Express and MongoDB. So there are JSON files flying back and forth between the front end and the back end, and that's how the website works. In this case, it's very similar. The front end is React, the back end is blockchain, and JSON files fly back and forth, allowing the app to work. So this is the GitHub link that I shared in the description of this video. I'm going to show you how to download it and install the app in your local computer. I could use Terminal to download the files, but I'm not gonna do it. I'm gonna do it in a very beginners friendly way. I'm going to download the zip file. So code download zip file is going to ask me where. I'm going to say yes, save here. It's downloading. I go to where it opened, which is here. And I'm going to extract the files from that folder. Great. So now it extracted the files. I go inside. This is the files that are on the GitHub. As of now, what I'm really interested in is this folder. So let's go inside that folder, copy the absolute path, go to terminal and cd into this absolute path. There you go, I'm inside, and I'm gonna put npm install. So it's a React application, and it has to install all the dependencies, all the React dependencies for the application to be functional. So that's what it's doing right now. Perfect. And just for you to see it more clearly, I'm going to put npm start. And there you go. Now the application is in your local computer, and you can work with it. So I want to show the app, how it works from inside. This is the code as it looks in Visual Studio Code. I want to start with this. So this is the import of the contract in the deploy component. You notice that it doesn't say tokenloans.solidity, which will be SOL, but rather tokenloans.json. So the contract that gets deployed is called token loans. That contract is also under the same license as Ethereum bonds. And is written in Solidity, but that contract cannot be deployed as such. It cannot be deployed as a Solidity contract. It has to be transformed into a JSON file that gets sent to the Ethereum blockchain. And I want to show the core of the deployment, which is these 3 lines. Notice here provider, and this is localhost. So it is localhost because I developed and I tested in my local environment using Ganache. But if you want to use a different blockchain, you will have to change this port of entry. You may have to change also this part. If you have questions or doubts, you can go to Ether's documentation which is pretty good, and you will find what you're looking for there. This syntax of these 3 lines is going to repeat somehow in every other function of the app. Let's go to borrower. This is the deposit function, and you will see a similar construction here, and also with port of entry. So lastly, I want to show the JSON file that is the contract. Again, this started as a Solidity contract, and then it gets transformed into a JSON file, which is the actual information that we do send to the blockchain. As you can see, it's very long and it's impossible to read for human eyes. So in this last part of the video, I'm going to show you how to compile a Solidity contract into a JSON file. Again, this is unnecessary if you want to use the application as is, because the JSON file is already in the source folder in the React application. I do this last part as completeness sake, so you have the source code of the Solidity contract and you know how to compile it. This is also useful if you want to create your own Solidity contract based on token loans. So this is contract compiler. These are the files that we downloaded from GitHub. This is contract compiler. If you go inside and go into contracts, you will see several contracts, including token loans. These other contracts are necessary in order for token loans to compile. These are other contracts that are open source that you can download, and specifically ERC20 standard. So in order to compile it, we go back here, we copy the absolute path, we come here to terminal, we go into the folder. Once in the folder, we're gonna write npm install, and this is going to install the node models, specifically Hardhat, which is going to be the development environment that will compile the contracts. So now it's installed, and we type npx hardhat compile, and 2 folders will be created, and one of them is artifacts. So we can go into artifacts, go into contracts, and you will see a folder created for each one of the contracts that were there. The only one we want to open, I mean, you can open any of them, but the one we're interested in is this one. And it has 2 files. We're interested in this one, tokenloans.json. That is the file that is in the source code in the React application and gets deployed. I want to show you one more thing, which is the development environment that I use for Solidity. It is called Remix. Here it is. It works on your browser. And I have open token loans right now. This is how it looks. It has all the nice colors to tell you what is what. And I want to highlight this part, which is the import. It is importing other contracts that make it operational. That's why you need the other contracts in place. These contracts on their turn import other contracts, and that's why in the end you need all these things in order to make token loans operational. I hope you enjoyed this video, and if you did, please give it a like. If you want to work together on a decentralized application, or you have another idea in mind, do write to me. My email is in the video description. Thank you.